Welcome to Crystal Clear Education Center. Here, learning made simple. We are going to deal with chemistry, and it's actually only basic chemistry. Have divided the basic chemistry into three parts. This is part one. I think it will be very useful for classes 8, 9, 10, and 11. If you missed something very important in basic, follow my video to catch it up. So before going into the video, today's quotation. Success isn't always about greatness. It's about consistency. Consistent hard work leads to success, and the greatness will come. Observe this video, something is happening. Very interesting thing is happening. He's constructing. He's building up. To build up anything, you need a strong base, right? So to build your chemistry, I'm going to give a strong base. So let us start from the matter. The matter, you can divide into three, like if we are categorizing. One, we are going to talk about the states of matter, then purity and changes. Like states, if you take it, solid, liquid, and gas, which you know basic, we'll be learning as a kinetic molecular theory. Another one, the Bose-Einstein condensate, that we call in quantum theory. Okay, and purity, if you take, the base starts from here. All these things we are going to learn in higher classes as we go into further videos. Purity, you take it, pure substance and impure substance. We are categorizing into two. Pure substance, where the properties do not change on further purification. You keep purifying the water. For example, you take water, river water, you purify, or the sewage water, you purify. Still the water remains water. So they exist in the same form. That we call it as pure substance. And the one we classify as compound, where you can see a fixed composition of elements. It is a combination of elements, in other words. Element, if you take like hydrogen, helium, lithium, okay, a group of atoms, same atom, which make up, that you call it as element. Okay, that cannot be decomposed by chemical, physical, or any other means. So the element we can classify into metals, non-metals. This is the these both are the broadest classification. Then metalloids, and then rare gases. Okay, all these comes under elements. Impure substance, if you take, depending upon the mixture, okay, it is nothing but combination of two or many substances, right? So we call it as a mixture, which is nothing but impure substance. Number one, we call it as a homogeneous mixture. Number two, heterogeneous mixture. Observe this word to our eye. To our eye, it looks like one single solution. It is a homogeneous, where you can see a separate substance, two substances, that you call it as heterogeneous substance, right? So salt water, air, and then alloy, all you take it as homogeneous. Heterogeneous, where they are in a variable composition. Okay. And next, changes. Physical change and chemical change. This is a very much base when we are going to deal with chemical reaction. You have heard about equation, reaction, right? It's all starts from here. When any substance react and they form a new product, we call it as chemical reaction. And basically what is happening? A chemical change is happening. Okay. Whereas in physical change, you can bring it back to the same thing. For example, you tear a paper into pieces. Okay, it's a paper you tear into pieces. Still the paper remains same, and you can bring it into the same thing, right? A clay, you take it, you make it as a toy and bring it back into a ball clay, right? So physical change is reversible, we can say. Chemical change is irreversible. Okay, so it's about the basic flow chart. Next, terminologies. Always terminologies plays its role, and we need to know the meaning of each and every word. In chemistry, these words you can very frequently see in your textbook, right? From 8th standard to 11th standard, even in 12th also, like atom, element, right? So first, what is an atom? You should know we are going from the base. What is an atom? It is the smallest particle of matter of an element. You can see it is a smallest particle of matter of an element. Not clear? Come on, see like this. For example, gold. You take gold. The gold is nothing but aurum. It's a Latin term. Okay, and the symbol for gold is AU. And you can see this is a gold atom. Like this, the gold atoms will combine together to form a element. Okay, and you can see a gold sheet or a gold earring, anything. So one atom alone, you take it and observe. It is having some other particles also, right? And that we are going to see very shortly in this video. What are those particles? Commonly, we call it as subatomic particles. So first, what is an atom? It is the smallest particle of matter. Okay, it is what matter? You can take it as a solid. Okay, gold, right? Next, what is an element? It is the substance that is made up of entirely of one type of an atom. So you can see this element totally made up of gold atom only. So it's a purest form, we can say. Okay, and here you can see the example, hydrogen. Okay, and some shell is going there. I think a circle is there. We'll wait and watch what is that circle about. Molecule. Next, two or more atoms chemically combined to form a molecule. You can see same. For example, you take this as hydrogen. Okay, same hydrogen. Okay, hydrogen molecule. Chlorine, chlorine molecule. Nitrogen, nitrogen molecule, like this, right? Compounds, if you take, it is a substance made up of two or more elements. Okay, so you can see it is nothing but NaCl. Okay, sodium chloride. Okay, an electron transfer. Shortly, I'll be teaching you what is this electron transfer. You can see the electron is moving and going to the next shell, chlorine, right? And they form a compound like sodium chloride, which is nothing but our common salt. Okay, then I told you, something is going around in the atom, some circular thing like that, right? So what is this actually? Mr. Bohr-Bure model, generally we call it as, he gave the energy shell. Energy shell, we can call it as energy level also, right? So he gave a proper structure for an atom with a good explanation. So let me see what he explained. He said, there is a nucleus, any element you take. I'll take the first element, hydrogen. Okay, H, you will represent as H. In molecular form, it is H2, right? There is an element represented as H. And here you can see the nucleus. And you can see the word nucleus, this part. Okay, this part. So in the nucleus, proton and neutron. So what is proton, neutron, electron? Observe the picture. Let me make it very clear. Electron, neutron, proton. All these three things we call it as subatomic particles. Mr. Dalton believed that atom, you cannot break it at all. It is indivisible, right? Then later came many other scientists, they said some subatomic particles are there. And Mr. Bohr gave it very clearly, it is nothing but proton, electron, and neutron. So proton with positive charge, neutron, it's the name itself says neutral, right? Electron with a negative charge. And this electron only will revolve around, you can see. And the proton is there in the nucleus. Okay, you can see something here. Okay, bounded together. That is nothing but nucleus. So this part, we call it as nucleus. In the nucleus, so let me write here, nucleus. Proton and neutron will be there. And around that, there is the imaginary, okay, pathway, which we call it as orbit. Okay, and in the orbit only, these electrons will revolve. Totally, how many subatomic particles are there? 3 subatomic particles are there. One is proton, another one neutron, another one electron. This proton and neutron will be inside the nucleus, and that gives you, let me write here, that gives you the mass. What mass? Atomic mass, or the mass of an atom. Mass of an atom. You can otherwise called as mass number, and it will be denoted by the letter A. Okay, this is another important thing. Later in higher class, it will be they'll be asking you to solve it or calculate the mass number. Okay, next, electron. This electron, which is revolving around this orbit, was named as a shell, and these shells are having energy, and we call it as energy shells. So the energy shells are, let me erase this, and I will draw you the energy shell. Now the nucleus is there. According to Bohr's model of an atom, this shell, we call it as K shell. Next to K shell will be L shell. Next to L shell will be M, and then N. One minute, yeah. N, okay. So K, L, M, N. These are the shells. And the shells, let me write here, K, L, M, N. We call it as main shells. Okay. About the subshells, SPDF will see in another video. And we call this as energy shells. According to octet rule, okay, how many number of electrons should be there? It is given as 8, right? And generally there is a formula 2n square. For K, n is nothing but the number of the shell. How many shells? This is first shell, second shell, third shell, fourth shell. We call this as energy level. Okay. Energy level. So 2 into 1 to the power 2 is nothing but 2. Number 2 to the power 2 is nothing but 8. So only these number of electrons can be placed, right? And 2, 3, 18, 2, 4, 16, 16 into 2. Okay, so this is the way we can calculate, right? So these are all the energy shells. So this plays a very important role as we go deep into the video. Next, these are the first 18 elements, okay, where you have to memorize the element in order. Take time to memorize the element in order. Okay, and the next to element, you can see the symbol. The first letter of the element will be given as a symbol. In many cases, except few cases where the Latin letter plays a role. Here it is natrium, so it is Na. Okay, sometimes the second letter will also be taken, so beryllium, and the for lithium. Okay, and sometimes the third letter will be taken magnesium. Okay, so observe it and learn this. And next to this, you can see the atomic number. Okay, atomic number is nothing but like position. Okay, we are saying in the order. So I'll go to the previous slide and I will show you what is an atomic number. We know mass number denoted by A, mass number. Whereas atomic number is denoted by the letter Z. This is a symbol, symbolic representation for mass number and atomic number. Atomic number is nothing but number of proton. Okay, whereas mass number is nothing but number of proton plus neutron is the mass number, right? So hope it is clear now. So the number of proton will give you the atomic number, not the electron. So you can see the proton number and you can see the atomic number, exactly same. Neutron will vary and both the thing together will give you the atomic mass. Okay, and you can see the electron number, proton number is equal to electron number, and that is why the elements are neutral. Okay, when they lose or gain the charge, based upon that will give a symbol as, for example, you can take we'll take sodium. For sodium, I'll be using a symbol F plus. Now it is not an element, it is an ion. That we are going to see in the next slide, right? So this is about the proton, neutron, and electron. And I told you about the shell, right? K, L, M, N. Like how many electrons can be placed in the shells. So observe this. And next comes here valency. What is the valency? The combining capacity of an element. We call it as valency. So the valency, you need to memorize the valency. So it will be easy for you to go through, right? And if you see the element, if you memorize the element in order, you will not memorize this in order. I'll tell you an easy way. Just observe here 1, 0, then the number goes 1 to 4, then in reverse order 3, 2, 1, again 0, 3, 2, 1, 0. Then 1, 2, 3, 4. This is a special thing where you'll have two possibilities, 3 and 5 valency. And then if you see the number again goes down, see the pattern, and it is very easy to write it. And as you go and get a hands-on experience, just like that, you can say the valency. Okay. If anyone need how to know the valency, I'll make a separate video for that. Now comes here, you can see the ion. So what I was saying there, an element, when they lose or gain an electron, they'll become charged particles. So the charged particles, you call it as ions. Okay, ions. Charged particles. And here you can see first element. Okay, and then you can see a polyatomic ion also. So there are two types of ion, cation and anion. Cation, if you say, it is positively charged. Anion, negatively charged. Okay, so can you guess right hand side and left hand side, which is positive charge and which is negatively charged? This you call it as anion, and this side is cation. Okay, depending upon the valency, the numbers are denoted. Okay, the valency for aluminium is 3, so it is Al 3 plus. The valency for chlorine is 1, so only 1 minus. Bromide ion, when you say element, it is bromine. Bromine. When you say as ion, it is bromide. When you say element, it is oxygen. Okay, this is elements. When you're going to say in element form. When you say in ionic form, it is bromide, oxide, because they have gained 2 electrons, they have gained 1 electron, like that. So based on that, it varies. Carbonate, bicarbonate. Okay. So one example I'll tell you. how the transfer takes place. Okay, how they are going to form a compound. Okay, like we are denoting, no, 2 electron, 1 proton, I mean, with positive symbol. So one example I'll tell you, sodium and chlorine. Okay, so sodium, if you take it, it is, let me draw and then I'll tell you. Okay, and if you place the electron, K shell 2 electron, then here 8 electron, next shell L shell 1, 2, 3, 4, 5, 6, 7, 8, 8 electron. Okay, another shell, it will be having only 1 electron. This we call it as structure of the atom. The atomic structure will denote like this. Okay, already in one slide I showed you the structure. Can you see the structure here? Sodium and chlorine, and even here you can see the shell. That shell is nothing but energy shell, right? And we'll come here. Yes. So the energy shell, how many energy shell? K, L, M. 3 energy shells are there. The outermost shell we call it as valence shell. Okay, depending upon the combining capacity will give the valency. And this shell is very much responsible in giving the valency. And if you see the electron, okay, the only electron will revolve around, right? So this electron is 1 and they are very much ready to lose and they become electropositive, Na plus. We call it as electropositive. Okay, so let me draw for chlorine. So it will be easy how the transfer is going to take place. Chlorine, you just observe here the atomic number. Sodium, if you take, it is 11. So the configuration 2, 8, 1, depending upon the shell. Similarly, chlorine, if you take the atomic number 17, the electrons are distributed in 3 shells, 2, 8, 7. That's what we are going to draw here. So how many shells? 3 shells. 1, 2, and 3. So 1, 2, 3, 4, 5, 6, 7 outermost shell. Okay, first shell only 2. After 2, it cannot be placed, so it is going to the next shell. 8. Next shell only 8 can be placed. Hope you know that. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So let me write the electronic configuration 2, 8, 7. 2, 8, 1. We call this as electronic configuration. Okay, now this electron will be transferred here and they become a compound. And you can see the electron will come here, they form a bond. We call it as ionic bond. Ionic bond. Okay, and this one is electropositive, whereas chlorine is gaining 1 electron is extra. Okay, actually, how many electrons should be there? The total number of electron, 17 electron. But 1 electron has come here to fill the shell and to obey the octet rule. And even here, they lose this electron. Actually, the number of electron, 11. Okay, they lose the electron, they become 10. Okay, that is why the positive, the proton number is still 11. Proton cannot lose or gain, it is in the shell bounded. So the proton number is 11, one proton is more, the positive charge is more. So it is Na plus, electropositive. And if you see chlorine, here the number is 17, still it is 17 only. But outside what happened? It has gained an electron, 1 electron. So it has become electronegative. Okay, and they both will bond with a bond called ionic bond and they become NaCl, sodium chloride compound, right? Hope we'll stop with this and we'll meet you in next video. Please go through this and subscribe the channel. Thank you.